Hello. So actually, in previous lectures, I delivered the lecture how to do sorting using heap. So we discussed about heap sort technique, but now we are going to discuss uh, a new program, but it is related to heap structure only. That is, in heap sort, what we did, we create an array. Then there was some elements or number of elements into that array. The number was previously given within the array. Then we convert that array into a heap. So all of the elements that will be in the heap that was given already, we just change the position of the array elements so that it can be converted so it could represent as heap. But now we will we will not discuss any sorting technique. Rather that we will discuss about heap. What is this structure? Suppose the heaps how to create a heap. Suppose there is you can suppose you can maximum accommodate suppose 10 number of elements into a heap. Then your if input is not given previously, what are those 10 numbers? Rather than we are giving a number, then we are constructing the heap. Then again, we are inserting another number, and after inserting number, a new number into that heap, again that heap structure will be lost. So again, we convert it into a heap. That means inserting node into a heap. After insertion, the total structure may not be it. So we have to, after insertion, we have to convert it into a heap. That means how to insert the node into a heap. That is the technique. So actually we will discuss about 3 operations on heap. First one is how to insert a node into a heap. Number 2, how to delete the root node from a heap. And number 3, how to replace the root node with some other node into a heap. So these 3 operations on heap we will discuss. And actually in heap sort, we did not use these, which of these 3 operations were used for heap sort technique. In heap sort technique, as already the number of elements which have to be sorted that was given previously, so it was created originally the elements were considered as a binary tree, then it was converted into heap. But there was no such operation, just how to insert a node into it, because already all nodes were given. But here the operation is something different. The heap will be there. We will insert nodes one by one, and after every node instruction, the total structure will be heap. So we are inserting a node into a heap, and after then again the total, so that the total structure will be a villa heap. It is not that we have given the simultaneous with the 10 elements, then we are just rearranging it into it. It is not that. Maybe we start from the 0th element. That means the heap is empty. Then we insert the node, then we construct the heap. Then we insert the second node. After inserting the second node, then it is converted into a heap. Then after inserting the third node, again a heap of 3 nodes will be constructed. Then after inserting the 4th node, a heap of 4 elements will be constructed. In this way, we are going to do the insertion operation into a heap. And while we are inserting simultaneously, we can delete the root node. Only delete is permissible only for the root node. So there will be 3 options. Either what operations can be done, that the operations can be done, either you can insert a node into it. Suppose the heap is full, then it will display that heap is already full, so you can't insert more nodes. Number two operation is delete the root node from the heap. Suppose a heap is empty, then it will provide you the message that heap is empty, so you cannot delete any node from the heap. The third operation is replace the root node with another node, with another with some other number. So with some new other number. So if the heap is empty, then it will say that it as root node cannot be replaced because heap is empty. And if this message are not displayed, that means the insertion can be done until the heap is not full. Once it is full, then it will show that further insertion is not possible. Either you delete the root node, then you insert the new node, or you can do either delete or replacement operation. So three operations were done, and in the heap sort technique, actually the operation of deletion was used. The operation on deletion was done, but no insertion was done there or not the replacement. Only the deletion operation was done for heap sort. And but here we will specifically deal with the heap structure and the operations which can be done on a heap structure that we will discuss. So heap is nothing but a binary tree, such that the root element of every sub-tree of this binary tree and is greater than all of its children. A binary tree can have only two children. One is left and another is right. So the root node of any subtree of a heap will be such that it will have it will have higher value than its children nodes. So sorting has already been discussed. That is different, but now we want to concentrate on heap structure. So we will insert nodes. Then after that, same as in next operation, we can delete the root nodes, or we can replace the root node. Then again we are inserting. Then again, maybe as any number of times we can insert the node. Any number of times we can delete operation on the existing heap node, or we can do the replacement operation on the existing heap node, or we can add or insert more node to this existing heap. So that total after insertion, it will again become a heap. That before insertion it was heap, and after insertion it also be a heap. Similarly, before deletion it will be heap, and after deletion also it will be heap. Or if it is a replacement operation, so before deletion it will be a heap, and before replacement it will be a heap, and after replacement also it will be a heap. So we will discuss all of this operation, that is insertion, deletion and replacement, one by one. So we are coming to that in the next video part. Okay, thank you.